All right, so in 3.1, we are going to look at how we identify functions. And so first, let's look at the definition of a function. A function is a relation or a rule that assigns each input, very big, exactly one output. So when we say input and output, what we mean is that each of our x values are paired with, once again, exactly one y value. So what we are looking for to determine if something is a function is that if each x only has one y. So below, what we're going to do is we're going to look at different representations of relations and how we can determine, no matter which representation that you're given, whether or not it represents a function. So the first representation we're going to look at is ordered pairs. If you are given a set of ordered pairs, what we are looking for here is that if we have the same x-coordinate and that x-coordinate occurs in more than one point, then the relation is not a function. So let's look at A. Again, we are focused on looking for the x-coordinate occurring more than once or in one point. So the x-coordinates are 3, 5, -1, and 5. So what you'll notice is we saw 5 twice. So since we see that x value of 5 twice, this is not a function. Not a function because x equals 5 has 2 y values. So again, since that x value of 5 repeats, it is not a function because it means that one x has 2 different y's. All right, if we look at B, once again, we are looking at the x-coordinate. We've got 0, 8, 2, and -3. We did not have any x values that repeated, so this is a function because x values don't repeat. All right, so now let's look at the next representation that you could be given. You could be given a table, and they could ask you if the table represents a function or not. So what you are looking for here is if the same x value occurs more than once, just like with our ordered pairs, then it is not a function. Remember, a table is just a bunch of x, y points, so we're looking for the same thing. Do the x values repeat? Do we see an x value more than once? So we've got 2, 3, 7, 9, and 10. There were not any x values that repeated, so this table is a function for the same reason, because no x values repeat. So then if we look at the table I gave you in letter B, this is a horizontal table, but still you're looking at this x-coordinate. These x-coordinates of these points are -2, -1.5, 2.5, and -2. So what you notice is right here, that -2 repeats. That one x value has 2 different y values. So this is not a function because x equals -2 has 2 y values. Each x can only have one y. So since -2 has 2 y values, it's not a function. All right, that's ordered pairs and tables. Now let's look at mapping diagrams. So what we are looking for here is that if more than one arrow is coming out of an x value, then it's not a function. So with these mapping diagrams, they're very similar to a table. The left is the x and the right is the y. So what this is telling me is this x value of 0 has a y of 5. This x value of 1 has a y of -4. And what we notice here is this x value of 2 has 2 different arrows. So what that means is that one value of x has 2 y's. So this first mapping diagram is not a function because x equals 2 has 2 y values. So in order to be a function, we want each x value to only have one line. And in this case, this value of 2 has 2 arrows. So since it has 2 arrows, it means this one x has 2 y's. All right, and then if we look at b, well, once again, these are my x and these are my y. And so if I look at these arrows, from -1, it just goes to 4. From 3, it just goes to 15. And 11, it just goes to 15. We don't care that these go to the same y. We just care that each of these x's only has one arrow. So b is a function because each x has one arrow. All right, this fourth representation we're going to look at is when we're given these discrete graphs. So these graphs that kind of look more like scatter plots because there's just individual points plotted. And what we're looking for here is that if a point is directly over another point, then the relation is not a function. So if we look at A, there's no points directly on top of each other here, or here, or here, here, here. There's some side by side, but we don't care about that. We care about, are there any points stacked on top of each other or directly over another? And there is not in A. So this first table is a function because no points are over another. So since we don't have any points that are directly over another point, this discrete graph is a function. Where if we look at letter B, well, right here in B, these 2 points are directly over each other. These are all okay, these are all okay, but because these points are directly over each other, that means these points have an x value of -3, but they have 2 different y values. So this is not a function because 2 points are directly over each other. Not a function. Those 2 points are directly over the other. This x value of -3 has 2 different y values. So not a function. All right, the last presentation that we are going to look at is continuous graph. And a continuous graph that is a function will pass the vertical line test. And what this means is that if I were to draw a vertical line on the graph, it's only going to pass through one point. So it will only hit that graph in one point. So if I look at A, I'm going to color the graph in blue just so you can see this V-shaped graph. That's my graph, not to be confused with the X and the Y axis. And if I draw a vertical line, it's only hitting that V-shaped graph in one spot. And it doesn't matter if I move that vertical line. No matter where I move that vertical line, it's only going to hit the graph in one point. So the graph in letter A is a function. And you can say because passes the, I'm going to abbreviate this, vertical line test. It passes the VLT. So that's a function because it passes that vertical line test. So then if you look at the graph in B, again, I'm going to go over the graph in the blue so you don't get it confused with the X and the Y axis. So there we've got this like S-shaped graph. And what you'll notice this time is if I draw a vertical line, I've hit that blue graph in 3 different places. So because I've hit that graph in 3 places, this is going to be not a function. And it's not a function because it doesn't pass the vertical line test or the VLT. So we need to make sure that a vertical line only crosses through the graphed relation in one spot. If it crosses through in more, then it's not a function. All right. So now that we've gone over all 5 different representations, I've given you one more of each just to kind of practice here. We are going to determine if they represent a function by writing yes or no, and then we'll say why. So number 1 is back to a set of ordered pairs. So remember with these, we're looking at these x values. So we've got 1, 2, 3, 4, 5. None of those x values repeated, which means number 1 is a function because no x values repeat. Each x value only occurs once, so that is a function. Number 2, I've given you one of those mapping diagrams again. So you're looking at how many arrows are drawn from each x value. So these are our x values. We've got one arrow, and what we notice right now here at this 2 is that there are 2 arrows. So this mapping diagram is not a function. And that's because x equals 2 has 2 arrows. All right, number 3 is a table. When we have a table of ordered pairs, again, we are looking at these x values, -3, 0, 3, 6, 9. No x value occurred more than once, so this is a function. Because each x value occurs once, which makes it a function. And we've got 2 more, our graphs. Number 4, we've got those points we're looking for. Do any of these points lie directly above the other? No, they do not. So number 4 is a function because no points are directly above another. So since no points are directly above another, it is a function. And then last one, which is not number 4 again, number 5. If we look at this blue graph here on our grid, this is where we can use that vertical line test because it's a continuous graph. And you'll notice if I draw a vertical line right here at x equals 2, it's gone through that graph in 2 spots. So this makes it not a function because does not pass the vertical line test. Not a function because it doesn't pass the vertical line test. All right, so that concludes our notes. You will go ahead and do the formative Google Slides and then the practice assignment.